Hi guys, here I've got a basic Atwood machine problem, and I'd like to find acceleration of the system, find T in the rope, and I'm told that mass 1 is 5 kilograms, and mass 2 is 2.5 kilograms. So let's begin with the forces on mass 1 and mass 2. So mass 1, we have gravity, which is going to be 5 times 9.8, or 49 newtons. We have a normal force, and we have tension. For mass 2, I have gravity as well. So that is 2.5 times 9.8, or 24.5 newtons. There's also tension. Now, something to note is that mass 1 will be pulled along the table by mass 2. So the direction of motion for mass 1 is in this direction, so I will call that way positive. As a result, tension is positive for mass 1. For mass 2, it will go down, so I will call that direction positive for mass 2. So as a result, the weight force on mass 2 is positive and tension on mass 2 is negative. So for part 1, it says find acceleration of the system. What I'm going to do is derive the equation without numbers and generalize it for you, and then we'll plug numbers in and solve. So I will write out F net for the system. The system composes of mass 1 and mass 2, so the system is mass 1 plus mass 2, and this is A, specifically of the system. All right, so if we start with mass 2, we have m2g, which is positive. And then we have tension, which is negative. And then if we flip over to mass 1, we have tension, which is positive. So tension drops out, and it will always drop out of the F net for the system equation. So I get acceleration as m2g over m1 plus m2. But if we generalize the acceleration equation for this particular system, so for a mass hanging off a table attached to another mass, with what we get then is the hanging mass times gravity divided by the total mass. From there, I can plug numbers in. So the hanging mass, guys, was 2.5 times 9.8 over the total mass, which is 2.5 plus 5. That is 9.8 divided by 3, or 3.27 meters per second squared. That's part 1. Part 2 says find the tension in the rope. I'm going to do this problem 2 ways. There are 2 objects, okay? And so the way I want to think about this is I want to split my system into 2 pieces. So I want to look at M1 by itself or M2 by itself. I'm going to do the problem with both masses to show you get the same answer, but you only need to do this one way. So if we start with part 2, I'm going to look at the mass on the table first. So this is mass 1. There's tension, gravity, and normal force here. This value here was 49 newtons. The direction of motion of the table mass was in this direction, so that direction was positive, so tension is positive. So if I write out just F net for mass 1, I get tension equals M1A. So tension will be 5 times 3.27, which is 16.3 newtons. Okay, that is a way to do it, and that is the easier of the two ways based on the complexity of the forces on mass 1. But the other way to do it, if I look at mass 2, we have gravity, and the weight of mass 2, as we recall, is 24.5 newtons. We have tension. This mass is moving in this direction, so that is positive. Therefore, the weight force is positive, tension is negative. So if I write out F net for mass 2, I get M2G minus tension equals M2A. So tension is M2G minus M2A. So that is going to be 24.5 minus mass 2, which was 2.5 times 3.27. So we get tension is equal to 16.3 newtons here. So guys, we have two ways to find tension. Both work equally well. Hope this was helpful. Thanks, guys.